Hello and welcome to another tutorial. We are looking at the last two items in the control flow statements in Java, which is the return statement and the yield statement. We saw that with return is used to control the flow of the method call, and we said that you can explicitly break out of the method call and return back to the caller by just using a return. And obviously depending on what the return type of the method is, in its signature you have to return the corresponding value, some value that the types match, right? And we said that sometimes you put a condition in and you try to branch out, and the other times you want to just basically, if you want to execute the entire body, you don't need to if the return type is void, you don't really need to type the return by itself, right? But if it's not void, then you have to have an explicit return a statement that returns something. And what we said then was that we can also look at the bytecode. So if I look at the return expression, open up the class file viewer, let's put them side by side, and let's look at the test one. All right, so in test one, we get this. Obviously the first line is here, and so we have this int, and remember, as I mentioned, is that if the method is non-static, this is pushed to the stack at location 0, but because this is a static, we're not pushing this. So the first thing that is passed to the stack frame of this method is this 32-bit integer. So this goes, x goes to the stack location 0, stack index 0, right? And then that's why you see when we want to basically check this condition, I load an integer from index 0 of the stack, right? Remember, if it's a 64-bit primitive like a double or long, then it takes 2 positions on the stack, because a stack in JVM is 32-bit. So in order to do this condition we saw this, it's basically a binary operator, and we always load the left hand side and then the right hand side, iconst 5, and we said that for integers there are 6 built-in integers, or 7 basically, 0, 1, 2, 3, 4, 5. They all use the iconst. And then if it's 6 or beyond, we use the push command, by byte integer, bi push, for example 6. But from 0 to 5 and also -1, we have iconst -1, right? These are hard coded constants which are typically used. And then obviously the if translates into this condition, as the argument of the if translates into the if compare not equal. So we are basically we check the fact that whether this condition, we are checking for equality in the bytecode, says that if they are not equal, right, between x and then 5, we compare them. If not equal, we jump to 22, and then basically we're not executing the body of the if, right? We just 22 is here, where we use the load the test1 invoked again right here, and then return. And basically, as you can see in the bytecode, the bytecode for return is just return, right? Because we're not returning anything. And then same here, when we have this return here, this just translates into a bytecode. It's just a bytecode is just return. This is literally a return bytecode for the return statement, right? Now what happens if we change this to, for example, int? Let's say we want to return int, and obviously now we have to return something. You cannot have an empty return. The compiler says that this method must return a result of type int. That's a must. You cannot avoid that, right? I can say return if x is 5, we're going to return 5. If x is not 5, we're going to return 10, for example. And now let's see how the bytecode changes. And I return. Now we are returning integers, so the bytecode changes to another bytecode which is called I return. And you can imagine that for other types like double types, we have probably D return. For object types or reference types, we probably have A return, right? Or everything related to the references, it has A as the prefix. Integers is I, right? Doubles is D. Float is probably F return. and but what yeah, so what we return, but we're not specifying what value we're returning, right? The reason is that when you return, what you return always is the last thing on the stack. So basically what the method returns, the return value basically is always the last element pushed to the stack frame of the method, right? I want you to understand again that this is all about the idea that the JVM is a stack-based machine, right? It emulates a stack-based machine, right? So for example, here in this case, we first basically push a let me paste this. We push for 10 we don't have a iconst basically bytecode. We have a bi push, which means a byte integer push this, and then push 10, we push the stack and return, and the JVM automatically returns the last value on the stack, which is 10. Same way here. Note that for 5 we have the iconst 5, so we first say we push this const 5, which is hard coded in the JVM, to the stack, and then we do a I return, which tells the JVM return the last value on the stack, right? So you always return the last value on the stack. Let's say we return an string, which is an reference type, right? So what happens here? And right now, as you can see, I am not getting a compilation error. The reason is that now in Java, it actually allows you to do explicit conversion. So let's say I say var x equals test1, and then sysout x. Let's run this. Let's see. So right now, I guess what happens here is that maybe we can let me close this. So let's see if it's possible to return an integer in place of a string. So I'm saying that a string x1 is a string x is test1. So it complains, right? Unable to initialize main class. So definitely you cannot do this. So we cannot return an integer. So the implicit conversion is not allowed. We can obviously say integer 5 here and integer 10 here, right? So let's close this. So this should work fine. We can run this, and 5, right? So Java doesn't allow you to do implicit conversions, and obviously for the local variable in the main method, I can also use var. That's perfectly allowed. Yes, because the compiler always knows the return type of a method call. Let's say here we pass 10. Let's run this, and then 10 test1 invoked again, etc. Right? Now, basically, now for the string, what we expect to see is a command for basically a bytecode for returning a reference type, something like a return. So let's have a look at this. Test1 a return. As you can see, we have the a return in both cases. The first one, we load a constant. For this case, basically what we're doing here, we are loading the load constant string 5. It's a constant string, and then we load it to the stack, and then we say that a return, which means return the last value on the stack. The type is reference type or object type. Whatever is returned, the compiler has to know the type, or the runtime also needs to know the type, right? So this is the return statement. There is one peculiar case where it's counterintuitive what happens. I'm going to show it to you. That's related to the try catch finally block. We haven't looked at in this course, but we're going to look at the try with try catch and exceptions later on. Here I'm just showing you what happens to the return. So public static, let's say we have a method that returns int, and then test2. We're not going to take any parameters, and I'm going to also comment this and say that we're going to invoke test2 here. But notice what happens. Let's say we have a code. Let me just make some room here. All right, so let's say we have a code that returns an int, but it might throw an exception. So we put it in a try catch, right? Try catch, and then finally. So the whole idea here is that if some exception throws, we try to do damage control gracefully handle it, but then we want to do also sometimes some cleanup. Obviously finally is not that common except when you're dealing with resources. But here let's say that int x is we're going to say that from the integer class, integer class has which is a wrapper type, has some parsing capabilities, parse int from integer. So we're going to convert this string to an integer primitive, and the whole assumption is that a string is purely contains a integer, right? And then we're going to say that return x. All right. We could even pass this as an argument, a string val, and then here we parse it, right? And then we return it. Now obviously we have one return statement, but this is still complains. Why? This method must return a result of type int, but we are already doing it. The problem is that if the exception is thrown, we're not returning, right? So the only way, so the compiler realizes that you're not covering all the possibilities in this in the body of this method. So there might be a chance that this line throws an exception, so this return never executes, right? We don't get to the return. So as soon as a line of code throws an exception, the rest of this part of the try is not executed, which means we never hit this return line. But we can, for example, say that, okay, if something happens, we return a default value, 25. Now the compiler is very happy because now it says that, okay, if this line throws exception, we are still in the catch, we have a return, so we have covered all the possibilities. Now let's see, let's say var x equals 5. And then sysout x. Now let's see what happens here. Obviously we expect the normal control, which means go into the try, parse it, and then return it. That's fine. But if I say 5a, this is obviously, this string cannot be converted to an integer, so we're going to throw an exception and return 25, right? Now this is very interesting that even if you put a return value in the finally, this still works fine. So this is not a compilation error. Now Eclipse compiler is giving us a warning that finally block does not complete normally. What this means is that, hey, if the try succeeds, we are already returning something. Why are you returning another thing? And I want you to understand or try to guess, if the try succeeds, if this line of code for parsing the value succeeds, and do we return x or do we return 10? That's the question. And in order to give you a background, now finally always executes regardless of whether your try block executes or catch block executes. So then the question is, let's say if the try executes and we pass 5 and then we're returning 5, but then we jump to finally and then we return 10. The question is it 5 that is eventually returned or 10? And the answer is going to be whatever the finally returns. And that's why the Eclipse compiler is warning us that, hey, you shouldn't overwrite the return statement in the finally, because we're kind of doing that. We are saying that regardless of what happens here, because finally always gets executed at the last. So this return is overriding every return that we had before. So if I run this, I get 10. Despite the fact that the catch was returning 25, but this finally is overriding that. So this is one of the small nuances, details about the return in this context of try, catch, finally. So my recommendation is that to never override the return statement in the final. So this is a bad practice. This is a bad practice. Never overwrite the return statement in the finally block, right? Never use a return statement unless obviously it's the return type is void. Then it doesn't matter. You don't need to explicitly write a return, right? So even if my try succeeds, I have a valid 5 here, the method is not going to return 5. It's going to return 10 eventually. So let's see. As you can see, it's 10. If I comment this out, so my finally is not doing anything, then it's 5. Now let's say I put a sysout here inside finally. So the question is, do we return x and then execute the finally, or do we before executing this return we execute the finally and then return the value? So as you can see, inside finally is executed, and then the return is this return, right? But if I say 5a, the catch block is executed, I'm returning 25, but the final is still executed. So in this case, because we are using the value, the return value outside, obviously the block, then eventually the finally from the method call chain, the finally is executed first, and then we get the return value. Now the final thing about statements is the yield. Yield is a relatively new keyword. Other programming languages like Python, they had it, but the concept of yield in Java is relatively simple at the moment. They didn't give it much flexibility. It's just about, so they've been trying to update the switch statement. So the last branching statement is the yield statement. The yield statement exists from the current switch expression it is in. So you can only use yield in the switch expressions. A yield statement, and remember that yield at the moment is part of the keyword. I'm not sure if they want to keep it, or maybe in the future because they're still experimenting with the switch and what can be done with the switch expressions, switch statements and expressions. So at some point they might maybe remove it. I'm not sure if it's finalized or not. Probably in the future we'll see what happens. A yield statement is always followed by an expression that must produce a value. This expression must not be void. The value of this expression is the value produced by the enclosing switch expression. So here's an example of a yield statement. We have an enum day, and then calculate, we pass a day, and for whatever thing that has a limited range, limited cases, for example enums are perfect candidates, we can use the switch expressions. We switch on the D. It's just a switch and case. It's pretty much similar to a bunch of if, else if, etc., right? So switch on D, and then case. So in the recent versions we can separate the cases with comma. So we say case either Saturday or Sunday, return this value with this arrow, weekend, the default return this body, right? Into remaining working day 5 minus the ordinal, and yield remaining work day. And the reason they did it, so they added this syntax for the arrow to return a single statement from switch. But then if you have multiple statements, you cannot use arrow inside the body. So instead, and then you cannot do return again, right? Because with switch you can't really, you have to break out of the switch and then return the value, something like that. So because we already have a return here, so they decided to add this keyword yield, which means we cannot use arrow here because the arrow is already there. So so they decided to add this to make this possible to return a value when you have multiple lines in one of the cases. So again, yield is something that you probably don't get to use that often, but that's something there. So this was the end of all these control flow statements. It was a relatively long discussion, but I hope you really enjoyed this. Next, we're going to go back to Java language basics and look at the switch, which is the last part of our basics of Java. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.